Hello and welcome to another episode of Amazing Astronomy, where we explore the wonders of the universe. Today, we are going to talk about the Sun, the star at the center of our solar system. The Sun is the most important source of energy for life on Earth, and it also influences the nature of space throughout the solar system. Let's get started. The Sun is a huge ball of hot plasma, which is a state of matter where atoms are broken into electrons and ions. The Sun is composed of about 70% hydrogen and 28% helium, and it produces energy by fusing hydrogen into helium in its core. This process releases enormous amounts of heat and light, which we can see and feel on Earth. The Sun is about 4.5 billion years old, which means it is about halfway through its lifetime. It is a relatively young star, part of a generation known as population I, which are stars that have higher metallicity than older stars. Metallicity is the proportion of elements heavier than hydrogen and helium in a star. The Sun has a metallicity of about 2%, which means it contains traces of elements such as carbon, oxygen, nitrogen, iron, and more. The Sun is the largest object in our solar system. It has a diameter of about 1.39 million kilometers, 864,000 miles, which is 109 times greater than the diameter of Earth. It has a mass of about 1.99 times 10 to the 30 kilograms, 4.4 times 10 to the 30 pounds, which is 333,000 times that of Earth. It occupies about 99.86% of the total mass of the solar system. The Sun rotates on its axis, but not as a single solid ball. Instead, different parts of the Sun rotate at different speeds, depending on their latitude. This is because the Sun is made of plasma, which can flow and twist under the influence of magnetic fields. At the equator, the Sun completes one rotation in about 25 Earth days. At the poles, it takes about 36 Earth days. The Sun has a complex structure that consists of several layers. The innermost layer is the core, where nuclear fusion occurs. The core extends from the center to about 25% of the Sun's radius. The temperature in the core is about 15 million degrees Celsius, 27 million degrees Fahrenheit, and the pressure is about 250 billion times that of Earth's atmosphere. The next layer is the radiative zone, where energy from the core travels outward by radiation. The radiative zone extends from 25% to 70% of the Sun's radius. The temperature in this layer drops from 15 million to 2 million degrees Celsius, 27 million to 3.6 million degrees Fahrenheit. The next layer is the convective zone, where energy from the radiative zone travels outward by convection. The convective zone extends from 70% to 100% of the Sun's radius. In this layer, hot plasma rises to the surface and cools down, then sinks back to the bottom and heats up again. This creates a pattern of cells or bubbles that constantly move and churn. The temperature in this layer drops from 2 million to 5,800 degrees Celsius, 3.6 million to 10,500 degrees Fahrenheit. The next layer is the photosphere, which is the visible surface of the Sun that we see from Earth. The photosphere has a thickness of about 500 kilometers, 300 miles, and it emits most of the sunlight that reaches our planet. The temperature in this layer is about 5,800 degrees Celsius, 10,500 degrees Fahrenheit. The next layer is the chromosphere, which is a thin layer above the photosphere that glows red during solar eclipses. The chromosphere has a thickness of about 2,000 kilometers, 1,200 miles, and it contains spicules, which are jets of plasma that shoot up from the photosphere. The temperature in this layer rises from 5,800 to 20,000 degrees Celsius, 10,500 to 36,000 degrees Fahrenheit. The next layer is the corona, which is the outermost layer of the Sun that extends millions of kilometers into space. The corona is visible as a white halo around the Sun during solar eclipses. The corona contains loops and streamers of plasma that follow magnetic field lines. The temperature in this layer is extremely high, reaching up to several million degrees Celsius, several million degrees Fahrenheit. The Sun also emits a constant stream of charged particles called solar wind, which flows outward from the corona and fills up most of the solar system. The solar wind interacts with planetary magnetic fields and creates phenomena such as auroras on Earth. The Sun also undergoes cycles of activity that last about 11 years on average. During these cycles, the Sun's magnetic field changes polarity and produces sunspots, which are dark areas on the photosphere that have lower temperature and stronger magnetic fields than the surrounding regions. Sunspots are often associated with solar flares, which are sudden bursts of energy that release electromagnetic radiation and particles. Solar flares can affect communication systems and satellites on Earth. Another type of solar eruption is a coronal mass ejection, CME, which is a large-scale explosion of plasma and magnetic fields from the corona. CMEs can travel at speeds of up to several thousand kilometers and carry billions of tons of material. CMES can also affect Earth's magnetosphere and cause geomagnetic storms, which can disrupt power grids and navigation systems. The Sun is a fascinating and vital star that we depend on for life and exploration. It is also a dynamic and complex system that we are still learning more about every day. Thanks to the advances in We hope you enjoyed this video about the Sun. If you did, please like, share, and subscribe to our channel for more amazing astronomy videos.